graphed linear functions before. Now we're going to graph linear inequalities. So if you remember, an inequality uses the symbols less than, greater than, or less than or equal to, or greater than or equal to. And there's going to be an infinite number of solutions for an inequality. So when you graph an linear inequality, so it looks like an equation except for there's an inequality symbol in it. You're going to want to use a solid line if it's less than or equal to or greater than or equal to. It means it includes the boundary line. This is called a boundary line. So if it includes the boundary, it's going to be a solid line. If it doesn't include the boundary, it's going to be a dashed line, and that would be for less than or greater than. Then there's two ways that you can shade, because just like we shaded on a number line, we shaded to the right or left. For an inequality, you can shade above a line and below a line. So the way that looks like is if you have a line, to shade above, because it can be sometimes hard to see where it's above, what I do is I put a ladder. I think of this as being a ladder. So if somebody were to climb up the ladder, in order for them not to fall off as easily, they would climb up on this side. If they climbed up on this side, they would be leaning way backwards. So I think about putting a person on a ladder, and if you shade above that person, you're going to shade above their head. Okay, so if you had to shade under, because it was less than, you would shade below. So for shading below, I'm going to draw another ladder. So suppose this is my line. If this is a ladder, I'm going to put somebody on a ladder, they'd go on this side. So shading below would be shade underneath the ladder, underneath where they are. So this is an example of shading below. So when you do an inequality, you have to figure out if you're going to use an open dot or a closed dot, and then if you're shading above or below. So the first one, it's an inequality because of this symbol. So I'm still going to graph it the same way. I'm going to find the y-intercept and the slope. So my y-intercept is 3, and my slope is -2. So I'm going to go down to right 1, down to right 1. And it's going to be a solid line because it has an equal to with it. So I'm going to make a solid line. Now the last step you have to do is you have to shade. So you're either going to shade on this side or this side. So in order to determine it, it's a less than or equal to the variable. Y is less than or equal to. So think about a person being on a ladder, which they'd be on this side. So you're going to shade underneath them. Okay, letter B. You're going to find the y-intercept and the slope. So the y-intercept is -1. The slope is 1. You're going to go up 1, right 1, up 1, right 1. Down 1, left 1. It's going to be a dashed line. The reason it's dashed is because it's greater than. It doesn't have an equal to symbol. So you're going to think about a person being on a ladder, which they'd have to walk up this way. And the symbol is greater than, so you're going to shade above that person on this side of the line. Letter C, it's x is greater than 2. So x is greater than 2 is a vertical line. So I'm going to make a dashed vertical line at 2. Now, this way, a person can be on each side of the ladder. They could be climbing up this way or this way. So what you want to think about is think of this x-axis being a number line. So where is this x greater than 2? Well, it's on this side, so I'm going to shade to the right. Okay, determine if the point is a solution. So if a point is a solution, it has to satisfy both the first inequality and the second inequality. So what I'm going to do is I'm going to plug in x and y into the first equation and see if the statement is true. So is 0 greater than -5? Yes, so that one works. In order for it to be a solution, it has to work for the other equation too. So I'm going to plug in 0, 0, into this equation. So is 0 less than or equal to 12? Yes, that's true as well. So yes, it's a solution. So for a point to be a solution, it has to be in the shaded area or of both inequalities when they overlap. And we're going to do a couple inequalities overlapping down here. Okay, letter B. So if I plug this in, this is x, this is y. Is 7 greater than or equal to 3? Yes, that works. Now let's check the second equation. Is 6 less than 4? No, it doesn't work. So since one of them doesn't work, it's not a solution. They both have to work. Okay, then at the bottom, solve the system of inequalities by graphing. So you can have a system of inequalities, which means there's more than one inequality, and where the shaded regions overlap is going to be your solution. There's going to be an infinite number of solutions. So I'm going to graph the first line in red. Y is greater than x minus 2. And it's going to be a dashed line. It's dashed because it's not including it. And it's greater than, so I'm going to shade above. And then this one, I'm going to start at 3 and change my color and go down 3, right 1. And it's going to be your up 1, left 1. It's going to be a solid line. And I'm going to shade less than. So I'm going to shade underneath the blue line. Now where the red and the blue intersects at the same time is your solution. So I'm going to darken that. I'm going to use actually black. So see how this part was red and this part's blue? This is your solution. There's an infinite number of ordered pairs that are satisfying the solution, so you have to shade. Okay, letter B. I'm going to graph the first line in red. So I start at 0 and go up 2, right 3. And it's going to be a dashed line. I'm going to shade less than. And the second one, it's going to be a vertical line at x is greater than or equal to negative 3. And where they overlap is going to be your solution.